Okay, so in 3.1 and in chapter 3, we're going to be talking about quadratics. So you have graphed quadratics before. They're a parabola. Okay, so we have a U shape. And then one thing we're going to find on the parabola is the vertex. Okay, so the vertex is either the highest point or the lowest point. And then you have what's called the axis of symmetry that goes through the vertex. If you look at the equation in standard form, you can see it's f of x equals ax squared plus bx plus c. We will be identifying a, b, and c today. And your a value can't be 0. If it was, there'd be no x squared. And what type of function would it be? The x squared went away. What type of function would it be? It would just be linear. Yep. Okay, so a can't be 0, and then the c value is the y-intercept. Okay, now we're going to talk about a few things related to your parabola. Okay, so you mean like here? So if you have f of x equals that, that'll be the same thing as the y or the output. Yep, the f of x is just your function notation. Okay, so for your vertex, this is going to be the highest or the lowest point. The highest or lowest point of the parabola. And this is called the max or the min. Okay, so there's going to be several words that represent the same values. Now, the vertex is always going to be in the center. So it's the center of your graph. So when we find that, we are going to put that in the center. Now to find the x-coordinate of your vertex, we have a special formula. Okay, so to find the x-coordinate of your vertex, we are going to know this, we are going to love this, we are going to use this over and over again. Okay, this is the opposite of b over 2a. That is going to give you your x-coordinate. Once you know what your x-coordinate is, you can always plug that back into the equation to find your y value. Okay, so the axis of symmetry and vertex are related. This is the line about which the parabola is symmetric. And remember, symmetric means it's going to be even on both sides. So we're going to use that to help us when we're creating tables. So the line about which the parabola is symmetric. The equation to find the axis of symmetry, you are going to recognize is something we just talked about. X equals the opposite of b over 2a. The axis of symmetry goes through the x-coordinate. So yes, those are the same. Okay, it is a vertical line that goes through the vertex. It's a vertical line that goes through the vertex. So whenever you are asked to find the axis of symmetry, you need the x equals. We're just going to write this notation here. You need the x equals anytime you're doing the equation of a line. So when you're solving for x, I'm not picky about like whether you have x equals 5 or if you just put down 5. We are picky about this because it's an equation of the line. Just like if I asked you to put something in slope-intercept form. If it was y equals mx plus b and you just had mx plus b, right, that wouldn't be the exact same thing. So we do need to notate that that is an equation. Okay, and then for the maximum values occur if the a value is less than 0. So if a is less than 0, That means it's negative, right? Then the parabola opens downward. If a is less than 0, the parabola opens downward, and the vertex is a maximum. We're going to draw a little picture to go with that. Okay, so if it opens downward, okay, you have the highest point here. This is your max. If you have a minimum, your a value is greater than 0. So if a is positive, the parabola opens upward. Okay, so if a is greater than 0, the parabola opens upward. Okay, and the vertex is a what? A minimum. Okay, I like the picture because it just reminds me, hey, if this is opening upward, I can see that I have a lowest value instead of a highest value. Okay, so this is your min. Okay, so when we are graphing quadratic functions, we are going to follow those steps below. So the first thing we're going to do is find the x-coordinate of the vertex, and that's because it's the center. Okay, so to find the x-coordinate of the vertex, we just wrote down that we are going to use this lovely formula. X is the opposite of b over 2a. Notice I keep saying opposite instead of negative. That's so if you have a negative, when you plug it in, you don't have to worry about making the negative negative. You just change it to a positive. And then we're going to create a table. It's going to have 5 points on it. When you create that table, you are going to put the vertex in the center, and then you can just choose 2 points to the left and then 2 points to the right. Okay, our next step is going to be the plot points from your table, and they should create a parabola. If they don't, something went wrong. So if you're connecting it and it's not a U shape, then I want you to go back and check. Okay, sometimes when I'm grading things, I see some interesting shapes. We know it should be a U. So if it's not, please double check your work. The last thing we're going to do is the domain and the range. What's really nice about these functions is your domain is going to be all real numbers because there's no restrictions that you have to worry about. And maybe you're thinking, wow, it's usually all real numbers for a lot of the functions we're studying. Yes, for a while, your domain is going to be all real numbers, and we're going to write them in set builder. So it'll be x such that x is an element of the real number set. Okay, and that's because you can plug in any number and get something out. Okay, when you have a linear function, when you have a quadratic function, yes, you're going to have all real numbers. For the range, though, this is going to be a little bit different. There are 2 cases that we're going to look at. We'll draw them here. So for the range, you either have a minimum value, okay, or you have a maximum value. So we're just going to write down the y-coordinate part, or the y part of this. So if you have a minimum, all of the points are going to be greater than or equal to whatever the y-coordinate of the minimum is. Okay, so it's greater than or equal to the y-coordinate of your minimum, which again, that is just your vertex. So whatever the y-coordinate is of your vertex, all of the points are above that. Whereas if it's a max, they are all below it. So that would be less than or equal to the y-coordinate of your max, which again is your vertex. Alright, so with those steps in mind, okay, we are going to graph the functions and state the domain and range. Okay, so when you are starting this, nope, not a calculator for this one. This is all mental math. Yeah, so if you have a equation here, we're just going to pick out our A value, our B value, and our C value. So go ahead and write that down. Okay, so back on our table, we wrote down that we had our A of x squared. Okay, so your A is always in front of x squared, B is in front of x. And then we also said how the C is the y-intercept. Keep that in mind as well. Okay, and then for step 1, you are finding the x-coordinate of your vertex. So to find the x-coordinate of your vertex, we are going to use our equation. X equals the opposite of b over 2a. Okay, so like I told you, if it's a negative, if you do the opposite, it's going to be positive 6 over 2 times 3. This is going to be 6 divided by 6, and that reduces to 1. Okay, that is going to lead you to step 2, where you are going to make your table. When you are making your table, whatever you got here is going to go in the middle. I'm going to just put a little box around it because this is going to be our vertex. Okay, now this is the x-coordinate of the vertex. This is also the axis of symmetry. I'm just going to call it AOS. Okay, because we are going to be putting this on our graph as well. Okay, so if you know the x, how do you find y? Yeah, you're plugging it. Okay, so we're using mental math for this. Okay, I'm a visual person. If you are too, you can plug it in. If you don't need to, that's okay as well. Okay, so when you do this, I just want to make sure that you remember your order of operations. So sometimes people will multiply here and then do the exponent. With order of operations, you have to do the exponent first. Okay, so 1 squared is 1, 1 times 3, 3 minus 6, plus 1, negative 2. Okay, to do your other values in the chart, you can just go 2 up, and then 2 down. Okay, I will try to keep them symmetric, because if they are symmetric, then you know they should match. If you plug in 0, shouldn't we already know what that is? What's that going to be? 1, because that's your y-intercept. And so that should be 1 also. Okay, so again, I would just do a mental math check, or sometimes I'll do like 2 squared is 4. 4 times 3 is 12, so I'll write down 12 minus 12 plus 1. I'll just write that part down if I'm doing it on a no calculator section. Okay, and then 3 squared is going to be 9. 9 times 3 is 27, minus 18 plus 1. I would add these together first. And then again, I would just check this. Negative 1 squared is 1. 1 times 3 is 3. 3 plus 6 plus 1, 10. Okay, so they should be symmetric if they're the same distance away. Okay, and now we are ready to plot. And then after you plot, see if you can do the domain and range. Okay, you are going to have to do this on graph paper and make your own grids. This is a 10 by 10, so I can just go by ones here. So 1, -2. At 2, I'm at 1. Okay, and we are going to put in the axis of symmetry. If you want to write that in beforehand, sometimes it's just helpful to see. You are going to label the axis of symmetry on your graph. When you put the axis of symmetry on your graph, it is a dashed line. So this is x equals 1. Okay, so this is new for you, right? Did you guys have to do your axis of symmetry in Algebra 1? You did? Okay. So as a reminder, your axis of symmetry is going to be a dashed line. Okay, that shows it's not part of the actual curve. Okay, but the reason why this can be helpful is when you're graphing, if you're at 310, okay, if this is 2 units away from the axis of symmetry, you just have to go 2 units in the other direction. So if you had 5 points on your graph, but you had more of it to span, you could use your axis of symmetry for that. Okay, and then this is a curve. Sometimes what I'll do is I'll do like the curve here. And then this is narrow. And then I'll connect them there. Yeah, so the domain and range is what you're going to do next. So we already talked about how the domain is always going to be the same. Okay, so your domain is always all real numbers. Okay, and your range is always going to tie to your vertex. So your vertex is 1, -2. You can always use the y-coordinate. If it's going up, then we're going to say y such that y is greater than or equal to -2. All right, and then I'm going to let you try part B. I'll check in a minute to see if you guys can find your A, B, and C okay. Can't tell you my secrets. Can't tell you all my secrets. And then once you have your A, B, and C, you can go ahead and plug that in to find the x coordinate. Okay, from there you can set up your table. Okay, so your A value is always in front of what? X squared. So what's in front of x squared if it's just a negative? -1, okay? And then B is always in front of x. Okay, do we have an x in here? No, so what's your B? 0. And then C is always the y-intercept, which is just that constant term. Okay, so when you go on to your next step, x is the opposite of B. The opposite of 0 is still 0. Okay, so you're going to get 0 there. Okay, so once you know what your center is, put that in your center. You could just do 1 and 2. If you wanted to do like 2 and 4, you could do that. Okay, that part is up to you. And then let's find our y's, and then you can plot and find your domain and range. What's nice about the vertex is it's also the what? For this one, it's also the y-intercept. Okay, and then if you plug in 1, you end up with -1 minus 4 to get -5. Okay, this would be -4 minus 4, which is -8. And whenever you have an exponent, do that first. This is going to be 1 times -1 minus 4, so you get -5 again. Okay, and for -2, you should get -8 again. All right, and then we're going to plot our points. So I have 0, 1, 2, 3, 4. I have 1 at -5, and -1 at -5, and then 6, 7, 8. So if it's 2 away, then I can go 2 away here. Okay, and then we're going to curve this. Alright, and then we're going to put our axis of symmetry on there. So I like to use a highlighter for my axis of symmetry, specifically for when it is on the axis. Okay, that way it's easy to see it, and then we are going to label that. So it's going to be x equals 0. Okay, so my point is 0, -4, that's my vertex. My domain, all real numbers. My range, because this is opening downward, now I'm going to flip it, so y is less than or equal to -4. All right. Once you have that done, in example 2, we're going to do an explanation. So I do want you guys to put the axis of symmetry on there. Okay, another way to think about your domain as well is, like we talked about in the first chapter, if you have arrows on both ends, this is slowly going out to -infinity. This is slowly going out to +infinity. And so it is going to be all the numbers. -1 is going to be to infinity. Questions for me on that part, on part B? Okay. When you are doing these examples, I'm going to help you set up what we're looking for here. So it says to compare the graph of f of x to a quadratic function g of x that has a y-intercept of 3 and a vertex at -1, 2. The question we have to answer is which function has a lesser minimum, and then we're going to explain that. So when you are finding which one has the lesser minimum in your explanation, you are going to find the actual minimums and then calculate the difference in units between them. Sometimes it's helpful if you have a graph like this to just plot this, because they tell you the vertex is -1, 2. So -1, 2 would be the vertex. If the y-intercept is 3, 1, 2, 3, remember the vertex has the line of symmetry on it. So if this is your line of symmetry, then you know if you're over 1 to the right, you can just go 1 to the left. And this is going to be your parabola. Okay, so this is the f of x that is labeled here for you. And then this is your g of x. Okay, so looking at these, can you guys tell what the lesser minimum is? It's going to be f of x. So the f of x minimum is 1, 1. We can see from our graph, over 1, up 1. The g of x minimum which we were told is -1, 2. So in your explanation, when you're talking about how much lesser one is than the other, you are going to look at this y coordinate. Okay, so what we're going to say is f of x has the lesser minimum and we're going to say because its minimum point 1, 1 is, and this is only 1 unit below, right? This is at 2, this one's at 1. Again, we're just looking at those y coordinates. So we're going to say is 1 unit below the min of g of x at -1, 2. Okay, so our explanation addresses this question. F of x has the lesser minimum, and then we're saying why, because its minimum point is 1 unit below the minimum of g of x. Okay, so make sure you have those key values in your explanation. Okay, and then once you have that written down, if you want to go to part B, question is similar, but it is presented in a different format. So go ahead and look and see what the question is asking you. Okay, so in this one we found which one had the lesser minimum. This one is asking you which function has the greater maximum. And again, it says to explain. Okay, so we have two functions, f of x, which they give us this equation for, and g of x, which says it's where? Where's our g of x? In the table. Okay, so let's look at the table. Can we figure out what the maximum is from the table? And if so, how can we do that? So I'm going to give you some time to look at the table. For some of you, you might find it very quickly. Okay, for others, you might need to chat with the people in your row. But I want you guys to come up with what the maximum is, okay, and how you know it. You can look at your table. And then talk to the people. With the person next to you different, let's talk about why, which one is the maximum. Okay, who's feeling good about what the maximum is in the table? How to put out your maximum? Yes, the maximum, isn't the maximum the highest y value? Okay, so then what's the highest y value? Okay. So this is going to be your maximum, the highest y. Okay. Also, did you notice that next to that, you start to have symmetric points here? Okay, so they didn't put their vertex in the middle of the table like we did. Okay, it's not this. Okay, because that's not your highest value. Okay, so your maximum for this one is going to be -1, 6. So your first step is to identify the max. Is the max always going to be what? No, because this isn't the middle one, right? Yes, will it always be the highest y value? Yes. Unless it's a local, but we're not doing that today. So, yes, for your parabola, the answer is yes. Okay, identify your maximum, your vertex for g of x. So that's what we just did. Negative 1, 6. We have the highest y coordinate. So if you want to write that down, it's just a little hint, you can. Okay, and then after we find the max for g of x, we also have to find the maximum for f of x. And again, remember that the maximum is just the vertex. Okay, now f of x doesn't have a table, so how can we find what the maximum value is for an equation? Yep, you can find the x-coordinate by doing x equals the opposite of b over 2a. So if I look at my equation, the opposite of my b value is what? 4. And then 2 times negative 1. This would be 4 divided by negative 2, which is, of course, negative 2. So that's your x-coordinate. Nope, so to find what your y value is, what do we do with negative 2? Yeah, we're going to plug that in. So instead of f of x, I'm just writing f of negative 2, okay, because that's what we're plugging in. So it's negative, and then parentheses squared. So we're going to plug in negative 2 here. So negative 4 times negative 2 minus 2. Okay, I'm going to give you a moment to try that, because these are the things that can trip people up on a assessment. Do you know your order of operations? Do you know how to deal with multiple negatives? All right, so you have to follow order of operations. The first thing we have to do is an exponent. So what's negative 2 squared? 4. 4 times negative is negative 4. Negative times a negative is a positive. Okay, so you have 8 minus 6 is essentially what you have there, or 4 minus 2, which is 2. Okay, so this is your y-coordinate. Your vertex is negative 2, 2. Okay, now we can compare. That's our third and final step. So we have to state which one has the greater maximum. So g of x or f of x. So we're going to compare. And don't forget to explain. Okay, I know that's something that you didn't do a lot last year, so we're going to work through some of that together. Okay, so we're going to identify g of x has the greater. So g of x has the greater max at negative 1, 6, because how many units more is it than your f of x? Yeah, so it's 4 units above the max of f of x at -2, 2. Okay, so in my explanation, I have identified both maximum values and I have identified the distance. Okay, so when you're doing the explanation, you want to include both of those points and then the distance between them. Okay, and then we are going to do example 3 tomorrow.